Very good morning, students. So, myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So, last class we have discussed about the robot dynamics. That part 1 we have completed. One particular topic we have completed. Today we are going to see the same unit 2 with upcoming some topics, some important topics also we will discuss today. So, this is the syllabus which we have already discussed in the previous session also. In this few topics we have discussed already. General expressions for kinetic and potential energy. Kinetic energy for N-link robot. Then potential energy also we have completed. Then Lagrangian equation we have completed somewhat. So the pending topics you will see in the upcoming slides. So equations of motion. That is, kinetic energy is assumed to be a quadratic function of the vector q dot of the form, that is k equal to 1 by 2 summation of I equal to 1 n summation of j equal to 1 n dij q qi dot qj dot equal to half q dot t d of q dot v equal to vq, which is independent of q dot. Euler-Lagrangian equation for such a system can be derived as follows: L equal to k minus v, which is equal to 1 by 2 summation of I equal to 1 to n summation of j equal to 1 to n dij q qi dot qj dot minus vq. The equations of motion: summation of j equal to 1 to n dkj q double dot j plus summation of I equal to 1 n summation of j equal to 1 to n dou dkj q by dou qi minus 1 by 2 dou dij q divided by dou qk. Outside the bracket you can put qi dot and qj dot minus dou v by dou qk, q equal to tau k, k equal to 1 goes upon to n. It can also be written as summation of j equal to 1 to n dkj q double dot j plus summation of I equal to 1 to n summation of j equal to 1 to n cijk qi dot qj dot plus gk, q equal to tau k, and k represents up to 1 starting from 1 to n. Then continuation of again the equations of motion, same the thing we will continue again. Cijk, that is half dou dkj q divided by dou qi plus dou dki q by dou qj minus dou dij q by dou qk. Then gkq equal to minus dou v by dou qk, or in matrix form dq d double dot plus c q dot plus g of q, which is equal to tau, where g of q is represented by g1 q, g2 q goes on gn q is a gravity vector, and ckj, which is represents summation of I equal to 1 to n cijk q qi dot, which is equal to summation of I equal to 1 to n half dou k j by dou qi q plus dou dki q by dou qj minus dou dij q by dou qk qi dot. This is the representation. Then a example for the two-link revolute joint arm. This having a two links, link L1, L2, having a angle of theta 1, theta 2. Now we can see VC1 equal to JVC1 Q dot. In the Jacobian matrix we have seen this. That represents Jacobian matrix represents, that is JVC1 equal to minus LC1 sin Q1 LC1 cos Q1 0 0 0 0. Similarly, again we are writing for VC2, that is JVC2 Q dot. The same thing is represented by JVC2 minus L1 sin Q1 minus LC2 sin Q1 plus Q2 L1 cos Q1 plus LC2 cos Q1 plus Q2 0. Then minus LC2 sin Q1 plus Q2 LC2 cos Q1 plus Q2, then followed by 0. So these are the basic conditions you have to take into account. So for the same thing, VC1 we are writing, as well as we are writing for VC2 also, that is JVC2 and Q dot. So hence the translation part of the kinetic energy is given by half M1 VC1 VC1 plus half M2 VC2 T VC2, which is equal to half Q dot T M1 JVC1 JVC1 plus M2 JVC2 and again JVC2 Q dot, then followed by omega 1, which is equal to Q1 dot K, and omega 2 equal to Q1 dot plus Q2 dot K. Omega I is aligned with Ki. The triple product omega I T I omega I reduces simply to I double 3 I times, that is 3 into 3 matrix, the square of the magnitude of the angular velocity. Let I double 3 I equal to II. Then the rotational kinetic energy of the overall system becomes half Q dot T, then I1 1 0 0, then I2 1 1 1 1 Q dot. Thus D of Q we can write as M1 JVC1T JVC1 plus M2 JVC2 JVC2 plus I1 plus I2 I2, in the bottom also I2 I2. It can also be shown that dW1 equal to M1 LC1 square plus M2 L1 square plus LC2 square plus 2 L1 LC2 cos Q2 plus L1 plus L2, and the D12, which is also written as D21, is equal to M2 LC2 square plus L1 LC2 cos Q2 plus I2. D22, which is given by M2 LC2 square plus I2. C111 equal to half dou D11 by dou Q1 equal to 0. Then C121 equal to C211, which is equal to half dou D11 by dou Q2, which is equal to minus M2 L1 LC2 sin Q2 equal to H. The same thing again we can write C221, which is equal to dou D12 by dou Q2 minus half dou D22 by dou Q1, which is given by H. Again C112, which is equal to dou D21 by dou Q1 minus half dou D11 by dou Q2 is equal to minus H. Then again we are having the expression half dou D Z divided by dou Q1 equal to 0. and the same thing half dou dZz by dou dz, which is also equal to 0. The same as for the potential energy also we are using the same thing, V equal to V1 plus V2. We are again utilizing M1 L1 LC1 plus M2 L2 Q sin Q1 plus M2 LC2 Q sin Q1 plus Q2, again using the derivative part of dou V by dou Q1, and same thing dou V by dou Q2. Upon simplifying, the final equation will get us tau 1 and tau 2. Therefore, the final case, in this case, C equal to the final expression will get us HQ dot 2 minus HQ dot 1, HQ dot 1 plus HQ dot 2, 0. So, these are the reference for your guidance, students. So, I use these references to prepare this content. Thank you all for your kind attention. This part is full of derivation part. So, kindly, symbolic representation is somewhat difficult. So, write and study. So, kindly subscribe the video and share this video to your friends. Thank you, one and all.